Find all the critical points of f of x equals x plus 1 squared all times 2x minus 5 squared. A number x equals c is a critical point of a continuous function f if c is in the domain of f and either f prime of c equals 0 or f prime of c does not exist. So to find the critical point, we're going to set f prime of x equal to 0 and solve for x. In this case, we don't have to worry about part 2 because there are no values such that the first derivative does not exist. So f of x equals x plus 1 squared all times 2x minus 5 squared. The derivative, f prime of x, requires the product rule. So the first factor we'll call a and the second factor we'll call b. Then f prime of x equals a prime b plus ab prime. So I'll go off to the side and compute a prime and b prime. If a equals x plus 1 all squared, then using the chain rule, we get a prime, which equals 2 times x plus 1. Again, differentiating b requires the chain rule, and that gives us 2 times 2x minus 5 times the derivative of the inside of the brackets, which is, again, 2. So we'll simplify this. Now that we have a prime, b, and b prime, we'll plug this into the formula we created. Now we need to set this equal to 0 and solve for x. To solve for x, I'm going to factor common factors from both terms. There's an x plus 1 common and 2x minus 5 common in both terms. So that leaves me with 2x minus 5 from the first term and 2 times x plus 1 in the second term. Now I'll simplify the contents in the square bracket. Now we have a product of 3 factors that equal 0. So at least one of them must equal 0. That is 2 times x plus 1 equals 0, or 2x minus 5 equals 0, or 4x minus 3 equals 0. In the first case, we get x equals negative 1. In the second case, we get x equals 5 halves. And in the third case, we get x equals 3 quarters. Since all 3 values are in the domain of f, then we have 3 critical points. And this completes the exercise.